Welcome to our presentation today. Before we start, I want to just do a couple quick things here. This presentation today is brought to you by the Diversity Inclusion Council, Speakers and Social Activity Committee. Kelly Montgomery is our chair for that committee. It's also co-hosted by the Women's Science and Engineering Council, Subcommittee Professional Development, which is chaired by Don Munson. So we're very happy to bring these amazing speakers to the laboratory, and I just ask your continued support for these two councils. They're pretty great. Oh, I'm sorry, and chemistry, because she's a chemist, so we partnered with the chemistry department from Ali and Tanya, and I was going to talk about that in just a couple of minutes. Before I get into introducing our speaker today, I just want to remind everyone that we have a couple more events coming up from the Diversity Inclusion Council Subcommittee. In October, we will host the Diversity Inclusion Cultural Fair. That'll be over by the cafeteria as it is every year. This, I think, is our 4th annual, something like that. And then in November, on November 11th and November 12th, we will be hosting in this room what we call Popcorn in a Movie. And the movie this month, or in November, will be Honor Flight, which is a tribute to World War II veterans. So if you have not seen that, I strongly encourage you to check out the trailer and then come and watch it with us on November 11th. And we're showing it for 2 days because it's an hour-and-a-half video. We'll show it in its entirety for both days, but some people may not be able to see all of it. Just 1 second. Okay. So I took up just the right amount of time, so before we get started, I wanted to introduce Dr. Lester, who will be introducing our speaker today. So some of you that are on the D&I Council understand that we've been working to try to get Ms. Brown here for more than a year. But her schedule and the honors and awards that she's received this last few months have delayed her visit here. When it was all secure and set up last year, the American Chemical Society decided to give her a Lifetime Achievement Award, and so she stayed in New Jersey for that. So she's here now. The Diversity Inclusion Council, as I've been talking about quite a bit, the Chemical Sciences representative is Tanya Cook, and Tanya brought her name to us and said she'd be a great speaker. She's an amazing woman, has done amazing things. Tanya has worked with Professor Lester, and so with Professor Lester and Tanya's assistance, we were able to connect with Ms. Brown and invite her here. So for that, we owe Professor Lester quite a bit. And with that, I will have him come up and introduce our speaker today. Thank you very much, and I'll see you in a little bit.
Thank you very much. I am delighted to have the opportunity to introduce Jeanette Brown. We've known each other longer than we care to say. Do I have that right? It's also fascinating to be asked to introduce her right now. I just learned about this responsibility. And so, rather than read from various other documents, let me read from the document that stands in front of me. Do I want to do this? No, I don't want to do it. That's too formal. What, 25 years at Merck, was it, Jeanette?
Yeah.
Yeah, and we met roughly when, Jeanette?
Oh, I don't remember.
You don't remember either?
Novachet sometime.
In any event, to make it short and to get to the facts of the matter, she's written this wonderful book, and let me recommend it to you, African American Women in Chemistry. And rather than take time to extol her many virtues, you will gain a sense of that from her remarks as we proceed. So let me take no further time, but pass this microphone to you, Jeanette, and say welcome to Lawrence Berkeley National Laboratory and the University of California, Berkeley.
Okay. Oh, thank you very much, Mr. Professor Lester. I know him as Bill. Okay, yeah, they taught me how to do this thing. Let's see what we can do. Here we go. Okay, the contents of this talk. Okay, I'm going to talk a little bit about the background information, and I'm going to talk about some of the women who were in my book. Not everybody, because there's 25 of them. You don't want to hear all 25, otherwise you wouldn't buy the book. I'm going to talk about my work in the labs when I was at CEBA and at Merck, and a discussion about research at Merck, including my work on Primaxin, which is an antibiotic, still on the market, thank you. And where African American women are in chemistry in 2014, it should be. I gave this at Novartis, and some things I forgot to change. And the path for all women chemists, now and in the future. Okay, I'm just an ordinary chemist who happens to be a woman and an African American. I heard an interview on TV about the CEO of Xerox Corporation that was done by Gwen Ifill for the History Makers, which is an online site that features oral histories of African Americans. The CEO of Xerox is Ursula Burns, and she is the first African American to become CEO. She said that she just happened to be a woman who was African American and interested in engineering and technology. I also felt that way when I was young, that I was just an ordinary woman who was an African American and wanted to become a chemist. When I was only getting started in my career, I found out that I was among the pioneer African American women in chemistry. And this was reinforced when I met Dr. Marie Daly, who was the first African American woman to receive a PhD in chemistry. I met her when I was a young chemist working at SIBA, and at that time I had met few African American chemists until I went to Novoshafer, actually, and then I went, wow, who are all these guys? Anyway, so I decided to do some research on the real pioneer African American women chemists. Okay, the history of African American women chemists. Why is this important to know this history? Well, according to the 1988 federal governance study, increased participation by minorities and women is crucial if America is to maintain its position as a world leader in science. And if you listen to our current president, listen for that sentence in every talk, world leader in science. And here are some statistics from 1988. White women, Native American, blacks, and Hispanics were only 14.5% of all employed scientists and engineers, but they are 64.6% of the population. Blacks compose 12% of the population, but only 2% of all employed scientists and engineers, with 5% of BS degrees and 1% of PhDs in science engineering. This 1988 study is from Changing America, the New Face of Science and Engineering, and it was the final report of the Federal Task Force on Women and Minorities and the Handicapped in Science and Technology in Washington, D.C. Now, the reason for the study. In recent years, major efforts have been made to illuminate the history of white women in science, and someone has written a 5-volume book about that. And I suggest an honest attempt to illuminate the experiences of black scientists, particularly black women, in terms of their struggles, strategies, successes, and scientific work can make a significant contribution both to the efforts aimed at increasing the participation of minorities in the scientists and the history of science in America. And until such studies are made and integrated into historical mainstreams, efforts to increase the minority population in science will enjoy only limited success, and the history of science in America will be made incomplete. And this is from Winnie Warren, who wrote a thesis on black women scientists in America, and she also wrote a book. And I just found out she just died 2 years ago. She was sort of my mentor for this study, although I never met her, but I have talked to her on the phone. Okay, where are the women? Well, delving into the history of African Americans in science, e.g. chemistry, most historians write about the history of African American male scientists, and none of them focus solely on the history of African American women chemists. Citations about the background history of African American women scientists are listed in my book. My book right now is still the only book which gives the lives of these women chemists. And the other source, as I said, is Dr. Winnie Warren's thesis and her book, black women scientists in America. Now, who were the first African American PhD chemists? Oh, the first male was St. Elmo Brady. He received a BS in chemistry from Fisk University in 1908 and taught at Tuskegee Institute, and then received a PhD in Illinois in 1916. And the first woman was Dr. Marie Daly. And you will note that a man was the first African American to receive a PhD in chemistry. And he also received it from a major Research One university back in 1916. He must have been a remarkable person, and the University of Illinois is to be commended for being a pioneer at admitting African Americans to receive a PhD. Credit must also be due to Brady's thesis advisor, Professor Clarence C. Derrick, because it was under his tutelage that he received the PhD. There was another African American, Dr. Percy Julian, who could not receive a PhD in the United States and had to go to Austria to receive his PhD. Other males also had the same experience in the early years of not being admitted for the PhD in major Research One universities. Many of them received their chemistry degrees from the historically black colleges, as did Brady. But they could teach at those schools with a BS or MS degree, but those schools were not PhD granting institutions until very recently. It is probably for this reason that the women who wanted to study chemistry did not or could not try to apply for a PhD until later in their careers. Since Dr. Daly spent most of her career in the North, in fact, she was accepted at Columbia University, is not unusual. We would also credit her thesis advisor, Dr. Lucretius Caldwell, for admitting her to her research team. Dr. Daly may have been the first had decided to apply for a PhD at New York University, but was left with only an MS degree. It is not known whether she applied for the PhD or was not able to receive a PhD from that university. I'm still looking that up. Okay, there's Dr. Daly in her lab. Okay, she was born in New York City on April 16, 1921. She went to Hunter College High School, which is a lab school for Hunter College, which was an all-women's school. And because it was a lab school, they encouraged all the girls in the high school to do what they wanted to do. And they encouraged her because she liked science. She graduated from Queens College with a high honors and later became Phi Beta Kappa. She had an MS degree from New York University and, as I said, PhD from Columbia. Her first position was at Howard University. She went there because she wanted to work for Rockefeller Institute in New York, but they wouldn't let her there unless she came and had a grant or had her own money. So she worked at Howard and applied for a grant from the American Cancer Society, and when she received that grant, she got to work with Mirsky in his lab. Her research focused on the areas of health and the effect of the heart, such as factors as aging, cigarette smoking, hypertension, and cholesterol. At Rockefeller Institute, with Mirsky and Alfrey, they worked on fundamental research on the chemistry of histones and protein synthesis. This is before anybody knew about DNA. So one of the papers from this research team, and which is noted on the board, the involvement of RNA in the synthesis of proteins, was mentioned in Watson's Nobel Prize Award lecture. Now, Watson has said something about women can't be scientists. I have yet to tell him that there was a woman, not only a woman, but an African-American woman who was in this paper that he cited. She went on, Rockefeller Institute became Rockefeller University, and all the people there, many of them, became professors at that university. Now, I've read some of the information. I went to the archives, and I don't know whether they didn't offer her a professorship or she saw some handwriting on the wall. But she went to Columbia University and worked with Dr. Deming. And then when Einstein College of Medicine was founded by Yeshiva University, she was invited to become the position of assistant professor of biochemistry and medicine with a salary of $10,300. It was good in those days. And it was mostly grant funded. So they moved their research to Einstein College of Medicine. Einstein College of Medicine was conceived in 1953 as the first medical school to be built in New York since 1897. The first medical school class entered in September of 1955, and the new research building was in 1964. Later in 71, she was promoted to the rank of associate professor because of her exceptional work as a teacher, mentor, and researcher. And she worked and mentored young women, minority people, to become doctors or biochemists or PhDs in biochemistry. They also have a biochemistry program there. And she retired in 1986. Okay, now I tried to find the oldest woman I could find who was a chemist, and right now she's it. Josephine Silone Yates, and I love the hairdo, all piled up on top of her head. She represents one of the women who was born in the North. She was born, there you go. She was born November 15th, 1859 in Mattatuck, Suffolk County, New York, and she was the granddaughter of a freed Long Island slave. Yes, we had slaves in the North. She attended schools in New York, but at the age of 11, she went to Philadelphia to live with her uncle and go to the Institute for Colored Youth, which was run by the Quakers. Her uncle became a dean of Howard University, School of becoming ministers, divinity school. And so she had to move and live with an aunt in Newport, Rhode Island, where she attended Rogers High School. And she was the only African American in the class of 1877, but she graduated valedictorian. Now, with her high school degree, she could teach in public schools in Newport, but she decided to go to the Rhode Island Normal School. Well, Normal School was a school, Hunter College started as a normal school, and that's what for becoming teachers, a teacher. It's now Rhode Island University in Providence. And she was the only African American to graduate in 1879. And then she later on got an MA degree from National University in Illinois. I have to find that school. It no longer exists. In 1879, she began her career as in the Department of Natural Sciences at Lincoln University, Lincoln Institute, which is now university, in Jefferson City, Missouri. It's an HBCU that was founded by former African Americans who fought in the Civil War, and then they came back to Missouri and said, we need to do something about people who are living here, and so they founded this institute. She became the first African American woman to hold full professorships at that college, and also in the United States. We haven't heard of any others. Where she was devoted to the education of students and taught chemistry there for 10 years. She's also an author. She wrote books and stuff. She has a pseudonym as an author. But you can read more about her in her book. And also, later on, she came back to the university to be head of the English department. She had to leave the university because she got married. And back in those days, women could not be married and work. So she had to leave. Okay, this is Alice Ball, and I'm talking about her because I'm going to work to make a national chemical historical site on the things that she has done. She was a granddaughter of a famous black photographer, and her parents were also photographers. Now, at that time, photo photography, you had to develop in the lab, so you had all these chemicals. So she was always around chemicals, so it was the reason why she decided she wanted to be a chemist. The whole family moved to Hawaii because her grandfather needed better air. They lived in Seattle, where it rains all the time. So they moved to Hawaii. And she went to school in Hawaii. Later on, she came back into Washington, the state of Washington, and went her undergraduate at Washington State University. And then when she wanted to get her master's degree, she was accepted at other colleges, but she wanted to go back to Hawaii. So she got her MS degree from the University of Hawaii, and she became the first African American to do that. And she taught there from 1915 to 1916. There she was recruited by Dr. Harvey Holloman to work on the Kalmuga oil problem. This oil was used for Hansen's disease, leprosy, but it was not very bioavailable. She was asked to make it more bioavailable. She was able to do this by synthesizing the ethyl esters of the two fatty acids, which made them more water-soluble and injectable. This was the problem that people with higher degrees than her worldwide had, but they could not solve. And it became the Ball method for Hansen's disease or leprosy. And it was used until World War II when they wound up with antibiotics and other drugs. She died at age 23 because back in those days, when you work in the lab, we didn't have hoods. And somehow or other, I think she had an overdose of chlorine gas, and she died. There's a little controversy about that. I've read her death certificates, and some say that she's white, but some say she died of other causes because they didn't want a lawsuit with the University of Hawaii. But actually, they have a day in the 29th of February became Alice Ball Day. And I don't know if it's every 29th of February or not, but anyway, they now are they have a monument to her at the University of Hawaii, and that's why we're going to try to make it a National Historic Site. Okay, here's Linda Mead-Tollin. Dr. Tollin is a biochemist whose research interests have included angiogenesis. It has to do with cancer. She wrote this, matrix malloproteinase expression and cancer-related invasion and metastasis. She has developed and modified an in vitro assay for angiogenesis in human microvascular endothelial cells, which was used to identify and purify potential angiogenic inhibitors and enhancers from desert fungi. And this research might also lead to cures for prostate cancers. Linda graduated from high school in West Virginia at the age of 16. She went to West Virginia State College and received a BS in chemistry in 1964. She chose the City University in New York for her graduate school in biochemistry and earned a PhD in 1972. She was also mentored by Dr. Daly, so she knows Dr. Daly. She knows one of her girlfriends was Dr. Daly's stepdaughter, and so she knows her very well. She worked at Rockefeller University for a while until she met her husband there. He was a visiting professor and at Rockefeller University, and they got married, and in New York, and she moved to Arizona, the University of Arizona, where he was the big biochemist there, and she was the trailing spouse. She had a number of research positions there, because she decided not to get a tenured position simply because her parents, she was taking care of her parents there, and she also had a daughter that she needed to take care of and so she's still at Arizona. She's now retired. and I met her. She lives in Tucson, Arizona. Now, I'm going to talk about some women who worked in national labs, and there's Betty Wright Harris. I've never met her. I want to meet her. She calls me at 8 o'clock in the morning. Now, she lives in Los Alamos, New Mexico. She's calling me at 8 o'clock in the morning. I said, "You're up?" "Oh, that's okay," because she has sold a whole bunch of books, and she's always looking for books for her relatives. She's known, if you have flown an airplane, you have touched or been touched by this invention. Betty Harris is known for her invention of a spot test for explosives, 1,3,5-triamino-2,4,6-trinitrobenzene, TATB. It's now used by the United States Department of Homeland Security to screen passengers to determine if they have nitroaromatic explosives. She's also responsible for the development of a Girl Scout badge, chemistry badge, similar to the Boy Scout. She worked in Los Alamos National Lab, and her job there was to clean up the mess when they did the testing of the atomic bomb. And she later worked for the Department of Energy Archives to work unclassifying documents. And now she's back in Los Alamos, retired, and living with her son, her son. Catherine Lawson. She, again, was a pioneer scientist at Sandia National Labs in New Mexico. And she's an analytical chemist who wrote a chapter in a book, Infrared Absorption of Inorganic Substances. She's also worked on the National Urban League's Black Executive Exchange Program, in which she had two interests. She wanted to advising young blacks about the quality and the extent of personal effort and commitment necessary to attain even small portion of the American dream. Her husband was also a scientist, and he worked in another area. But these two people, this couple, were rock stars in New Mexico, in their town where Sandia Labs are. And so there were only a very few African Americans lived in the town, so they were invited everywhere, and they were speakers and everything else. And there's an Ebony magazine article about these two people out there in New Mexico, African Americans. Jenny Patrick. Okay, Jenny Patrick was the first African American to get what she calls traditional chemical engineering. I have another woman who chronologically was first, but she was not the regular traditional chemical engineering. But Jenny Patrick is. And Jenny Patrick I met at Nobuche. Her PhD in chemical engineering was MIT, but her undergraduate degree was from UC Berkeley. She started at Tuskegee Institute, and they started a chemical engineering program there. And then they didn't have enough money, so they dropped it. And she was in the program, and so she had to work for a year because she had had a fellowship at Tuskegee. She had to work for a year so she could come back to Berkeley to get her undergraduate degree. She's a very feisty lady, even when she was a child. She integrated the Gadsden, Alabama High School. Now, she at the time, it was just time when Brown versus Board of Education, well, she could go to the all-white high school or go to the black high school. She wanted to go to the white high school because she was interested in science. Teachers, students, everybody hated her, mocked her, hurt her, but she graduated, and she graduated with high honors from there because she's such a feisty lady. She just wouldn't take no for an answer. And she was the first person to develop the pioneering research program in the area of supercritical technology and supercritical fluid extraction technology, which is high-pressure separation of purification and units of distillation. She's living in Georgia now, semi-retired, I think. Okay, here's a woman who's going to be in my next book, Dr. Sondra Akins. She has a PhD in chemical education from Florida State University. But her undergraduate degree is from UCal Berkeley, simply because she met her husband, and he was getting his PhD in chemistry at Berkeley. So she just followed him along and said, okay, so she got her undergraduate degree here. She believes that she is the first African-American woman to receive that degree. You have to, it's hard to do this. I did the same thing with Minnesota. You have to look through the catalogs, because nobody really took any data. She teaches chemical education at William Patterson University, and she's a history maker. You can go online, well, I don't want, you can get her bio if you go online and look for her on history makers. Her husband is a PhD chemist at City College, and as I said, she will be in my next book. Okay, here's another woman I would love to meet. She lives down South Bay, way down Silicon Valley. She was the first confirmed by the 106th Congress as the first African-American Undersecretary for Commerce and Science under the Clinton administration. And then she became that she was the highest ranking black woman at Intel Corporation. She also worked for HP, all the others in Silicon Valley. And she now has her own company, Global Smarts, which is a Silicon Valley firm. She's also a speaker. She a paid speaker. I'm going to try to get her to come to the ACS meeting sometime. And I'd love to meet her someday. Okay, we're down to me. Okay, a pioneer organic medicinal chemist who was among the first African-American women to integrate two pharmaceutical companies, Ciba, now Novartis, and Merck Research Labs. She's a member of the research team who worked on a component of the broad-spectrum antibiotic Primaxin. Okay, now I showed this one because I don't know how many of you are chemists, but this is what our labs used to look like. We had large stuff. Okay, my undergraduate degree is from Hunter College in New York, which at the time was an all-women's college. It became, and it's now co-ed. But if you look at the alumni, there's mostly the women there. The men are still there, but I don't know. Anyway, and then I went to the University of Minnesota. Did I skip that? Let me go. Where are we? Let me go back. Okay. So then, after I graduated from Hunter College, I decided I wanted to work, well, I was going to first be a doctor, but it would be hard to get into medical school. And I love chemistry. So then I decided, let me go get a master's degree. Now, this is 1956, before the Civil Rights Act. So in order for me to get a job in industry, pharmaceutical industry, that somebody with a BS could have gotten, I had to have an MS. So I picked a school. I picked it the wrong way. I looked at catalogs, and I looked at pictures of the catalog. Oh, Minnesota, why not? I thought I was going to the West. I'm in the middle of the dorm in Minnesota, and they said, you're in the Midwest. Okay, fine. So anyway, I love Minnesota. It's great. Anyway, so this is my lab, and there was a big, that lab is now no longer exist anymore, but that was where they all put the people who were going to get their MS degrees, because we were all bunched together. Okay, so I got an MS degree in organic chemistry in 1958, and I have the thing. I'm an only child, so my mother and father had to come and see me graduate. And I have a thesis, MS degree, and my thesis advisor was Dr. Kelch. Now, Dr. Kelch gave me a thesis problem that he was working on, and he would have given to a PhD. I went, oh. I just found that out lately, because I had some publications of his, and I said, oh my God. But anyway, we got it done, and I graduated in '58. Okay, when I applied for jobs, I applied for SIBA, Hoffman LaRoche. I applied for all the pharmaceutical companies in New Jersey because I lived in New York, and most of them were in New Jersey anyway. I got 2 job offers, and SIBA was first, and the other company came in second, but my father said, you have a job, take it. So I did. So I started as a junior chemist in SIBA. It's now Novartis, I said. And my boss was Minnesota. Oh.
Go back one.
Okay. How does that jump?
There you go.
Oh, I wait. Okay. So my boss was Dr. Rennet Mazzoni. In the lab, we had 3-person teams. 1 senior PhD and 2 juniors. Jerry Boxer was the other guy. I mean, we all had MS degrees. Okay. I began my research. My first project was tuberculosis, and I'm jumping up and down because I love this thing. TB was an epidemic in New York, and when I was a child, and we worked on it for a while, and then you find out. Then that's when you find out about the economics of working for a pharmaceutical company. My boss comes in, drop everything. We're going to no project. Because it was not cost effective since it was very little TB in the U.S. and it was only academic in third world countries where a drug could not be sold at the time. And so it was the first time I realized the economics of working for a pharmaceutical industry. Company needs to make money on the drugs, and I was upset. Okay, I was supposed to talk about labs back then. Okay. For nowadays, when you work in a lab, you work on milligrams, micrograms, small amounts of stuff. I had to make 5 grams of a product for testing. We tested on animals, not microbes. Therefore, I've started working with reagents in a 12-liter flask, and you saw one back in my lab, in which the reagents were stirred in reflux for hours. And then you evaporated the solvents using a rotovac and removed the impurities by crystallization. You don't do that anymore. Now you do column chromatography. So we crystallized the compound until it was pure. Lots of old drugs are not really that pure, but they're still on the market because we didn't have NMR at that time. We couldn't analyze the product as it was sent to a lab.
Sorry to interrupt. Can you turn your microphone off and on because it's making a fuzzy noise? So turn it on.
No, I'm not turning it off and on.
No, they want you to. They want you to turn it off.
Oh, okay.
And then turn it right back on.
Okay.
That's what we're hearing from up in the box. Thanks.
Okay. Okay.
Sorry.
Okay. We didn't have NMR then. Okay, one of my jobs at SIBA and later Merck was coccidiosis. I'm glad I'm talking before lunch because this is the Animal Health Project. Coccidiosis is a disease that is caused by the protozoan parasites of the genus Eimeria, developing within the intestines of most domestic and wild animals and birds, chickens. And in order for chickens to be on the market really fast from the egg to the chicken that you eat, you have to have a chicken that doesn't have this disease. And so what we were developing are coccidiostats. These were drugs that would stop the protozoa from growing long enough so that we could harvest the chicken. And the drug that we made had to be very potent because it was in the chicken feed. It had to also be very cheap because farmers would not buy chicken feed if it were expensive. So it was not an easy project. Nowadays, they have they can inject the egg and get rid of it. So it doesn't happen. But back then, they didn't have this. And I think they still make some coccidiostats. So this is the drug which we made. Back in those days, in the companies, you have a number. Before it has a name, it has a number. So it was SU. SU is Summit. That's where our labs were, and that's the number of the drug. And as an anti-coccidiostat, you'll notice it has cyclopropyl groups on the end. I will talk to you about the fact that as I was working on my projects, I was the lady that would like to put cyclopropyl things, because I did that in my grad school program. I was a cyclopropyl kid. So I like to do things like that. And so this compound is well tolerated and effective coccidiostat. Now, this is all going to be chemistry. I'm going to run through it because you're not interested, but you need to know exactly what all the work we had to do. And you notice there's my cyclopropyl compound, and it goes on. And if it's a parenthesis, that means we didn't isolate that. Or if it went that way, we got the wrong thing. But when we went that way, we got the right thing. So, okay. After I moved to Merck, they hired me actually because I had this expertise in coccidiosis. But when you leave one company and you go to another company, you sign something that says you will not work on that project for 3 years, which I did. And about probably the day when they figured that was over, I started working on coccidiosis again. And because one of the things is the protozoa become immune. So you always, back then, you always needed a new coccidiostat. So you always needed a new drug. So again, I did the cyclopropyl, and we came up with Arpacox, which is there. Arpacox. There at Merck, okay, MK again, that's Merck, 302. That's the name of the drug, and that's the number of the drug. And then later on, it gets a name and a generic name, and Arpacox. So Arpacox. Okay, now we're going to talk about Primaxin. Okay. Primaxin is a potent antibiotic, and it's still used. If you're on Primaxin, it's an injectable compound. If you're on Primaxin, that means you're very sick because it's a very potent antibiotic. And it consists of an antibiotic that's a carbapenem, imipenem, and an inhibitor, renal dipeptidase or dehydropeptidase inhibitor. This is 2 drugs. I did the research for the inhibitor, and it was presented to our team by a biologist because the antibiotic was not going to work in the kidney. And if you want a potent, full-body antibiotic, it has to work in the kidneys as well. So the biologist went through, in pharmaceutical companies, you've got a whole bunch of chemicals that you can test. So he tested a whole bunch of chemicals and found one he thought would be good. So he gave us the structure, and we had to make sure that that would be our lead compound. And we had to develop the lead by making analogs. And as I said, I make cyclopropyl. Okay, this enzyme, it deactivates the compound as it goes through the kidney, gives you low antibiotic levels in the urinary tracts, which means we had to find drugs that would make sure that the antibiotic would go through the urinary tract. And the compound that we made was called Cilostatin, MK709, and has the desired pharmacological properties and has been chosen for combination with our imipenem. This is from the paper. Now again, I'm running through a whole bunch of chemical syntheses that we did to make the compound. Most of the target compounds in this study were prepared by a one-step reaction between an alpha-keto acid, which is there, I figure out how to work this. Anyway, it does it too? Oh. Okay. Hello. Oh, there. Alpha-keto acid. And then this is how you make the compound, and these are the starting materials and stuff. And a primary amide. Nearly all the butynates I guess a table, were made from the Wright alpha-keto butyric acid. And it was continued until we got the azolactone, and then it was isolated and hydrogenized to the butynate. Okay, this next one is, again, this is all the work that has to be done. And you wonder why drugs are so expensive. But if you see all those analogs here, all of them had to be made, and they were all made by somebody. So we spend a lot of time in the lab doing all of this work. And again, there we're getting to my cyclopropyl compound. And again, and again. Okay. Primaxin. So the drug Primaxin is the imipenem and cilostatin sodium. It's a sodium salt of that. It's a suspension, is a formulation of the two. Both compounds, when you do this, and pharmaceutical companies don't want to do this much anymore because you made both compounds. This one had to go through the tests, through human, 3 different kinds of tests. The inhibitor also had to go through the test, and then the combination has to go through the test. And all of this data in the lab and all the analysis people all have to keep all this data. It goes to the FDA, and then finally, when the FDA thinks it works, then it becomes on the market. So it takes a while. So companies like to find one thing that will do everything that they want. But Primaxin is still on the market, and they're still using it. Okay, here are the final structures of the two compounds. Hello. I'm not getting anything.
Yeah, this one.
Oh.
There you go.
Okay, that's the imipenem. That's the compound. This compound was found, because it's an antibiotic, was found from soil sample. The original one, soil sample in New Jersey. When we were in the lab, we were told to bring home soil samples so the biologists could find antibiotics. And then we would work on them. So that one was from a soil sample in New Jersey. Here's my inhibitor, and there's your cyclopropyl compound. It's cycled around, but that's the cilostatin sodium. There's the sodium. It's a sodium salt of that compound. And these two combined are called Primaxin. Okay. Now we go back to the fun stuff. current African American women chemists. And young women are entering the field and receiving degrees on the way to PhD level. And I was just at the last Nobuche meeting. That's where I got the award, not from the ACS. I got the award from Nobuche. They're running this show. When I first joined Nobuche, it was all chemical engineers and men. Of course, I'm single, so I was looking for the men. So I had fun there at Nobuche. But now we've got women, we got women vice president and all kinds of stuff. That's what I'm saying, Nobuche, National Organization for the Professional Advancement of Chemists and Chemical Engineers. Nobody calls it that. We call it Nobuche. And some women are entering industry and academia and moving up in their profession. But there are still obstacles in respect to advancement. They're not advancing as fast as white women are. There was a program that the American Association of Scientists called the Double Bind, where they got as many minority women scientists together to talk to them about how they were advancing in their careers. And there's a whole paper on the Double Bind, which you can read online. That was 35 years ago. Recently, there was a Women of Color program, which was done by the, I forget now, Women of Color Symposium that I attended. And again, they got minority women. When they're women of color, they included Asian women too. Asian, Hispanics, African Americans. And when I heard the stories about these women at the Women of Color Symposium, and I had read the stuff about the double bind, in 35 years, not much had changed. And we were really upset with it. The ACS has a Women of Color group now, and which had met at the last meeting over in San Francisco. So we're still working on it. Women chemists in general are still earning about 15% less than the men in the same company. You can look at the American Chemical Society salary survey, and I didn't look at the recent one. It's published November. It hasn't been published for this year. I'm a career consultant for the ACS, and so I advise young women to, if they have buddies or or applying for the same company or they know people, find out what the men are making, and then ask for the same salary. It is sort of known that women don't ask. They need to ask. The men will sit there and say, and the women will go, and they'll take what they can get. You gotta ask. And recruiters are still looking for the people who have the expertise that they need to fill that position. Keep your resume up to date all the time, even if you're working. You never know what might happen, and find a position. Now, just recently at the ACS meeting, I found out that we're cranking out more BS chemists than there are jobs in the United States. So what do we do with BS chemists? Well, when I talked to somebody, they said, remember, you have the credentials. You know how to do research. You know how to work with numbers. You know how to write a proposal. Think about other jobs where you can do the same, use these skills. When I go to buy a refrigerator, I do research first to find out what the best refrigerator is. So that's the kind of skills you can use in other jobs. The numbers of PhDs and MS chemists are keeping track. They're about the same. I asked about the BS going on to MS or PhD, and then I forget about the fact that you have all of these. You have to pay for college, since I had free college, and they may have loans and stuff that they have to work about. But I know the University of Minnesota, they teach freshman chemistry in rooms like this. They need teaching assistantships, a teaching assistant. I was a teaching assistant. So, apply to a major university for a TA job. All they can do is say no, and so that would help you through your career. And so that's what I tell women in general. Okay, I'm almost through. Final words. Okay.